Okay, so we're going to look at an example of a totally inelastic collision problem. It's number 4 on page 11. A 5 kilogram lump of clay moving to the left at 10 meters per second strikes a 6 kilogram lump of clay moving to the right at 12 meters per second. The two lumps stick together after colliding. Find the final speed of the new lump and its direction. Okay, so first I'm going to label the problem. So it's page 11 in the packet. Number 4. So basically we have one lump of clay with a mass of 6 kilograms moving at 12 meters per second and another lump of clay moving in the opposite direction at 10 meters per second, and it's 5 kilograms in mass, and they stick together and become one mass. So what I'm going to do is start off the way I would start off any collision problem, and that is labeling everything. Okay, so I'm going to call the 6 kilogram object mass 1. So mass 1 is 6 kilograms, and it has a velocity of 12 meters per second. And then object 2 has a mass of 5 kilograms, and it has a velocity of, I'm going to call it negative 10 meters per second. And the reason I use negative 10 is because it's in the opposite direction. Okay, and then the question is, if they move together after the collision, how fast? So I'm just going to use the symbol V for after the collision. Okay, I know that in any collision, the momentum before the collision has to be equal to the momentum after the collision. Before the collision, I have two separate objects. So to find the total momentum of the system before the collision, I have to find the momentum of each object separately. So that's the first mass times its velocity plus the second mass times its velocity, because I have two separate objects before the collision. Then they collide, and after the collision, they stick together. So they're going to be moving as one mass, moving at one speed. So the way I'm going to write that is I'm going to put a parentheses and put the masses together because they're basically stuck together, and they're moving at one speed together. Okay, and I want to solve for V. So all I need to do is divide both sides by the quantity M1 plus M2. So that's exactly what I'm going to do here. And then this cancels out and I have V. Now I can plug my numbers in. So I have 6 kilograms times 12 meters per second plus 5 kilograms times negative 10 meters per second divided by the total mass, which is 6 plus 5 is 11. Okay, 6 times 12 is 72, and 5 times negative 10 is negative 50. So the top of this fraction is 22 divided by 11, and I get V equals 2 meters per second, and that's my answer.